Thank you, everyone. Hope everybody's having a good day today. I'm James Kirkland. I'm Chief Architect for Internet of Things at Red Hat, and I've been working with the Eclipse IoT group for two to 3 years, somewhere in that range, generally want to have a discussion about why I think that building an open source IoT cloud platform matters. Why it's really important that we have. There we go. Why it's really important that we have one, because there are a lot of ways that you can solve problems with IoT in particular. If you look at it, it's sort of a Goldilocks solution. You can have the proprietary solution where you go to one vendor, large industrial company, and they provide you everything you need to run your manufacturing plant or run your railroad or whatever, but you're buying all of your software, you're buying all of your hardware, you're buying everything from that vendor. So you're essentially locked in to that vendor. They may have some plugins that allow you to integrate SAP or integrate some other software, but generally that model is very monolithic. You have very little control. And if you look at SAP implementations and other implementations like that, with that monolithic model, you typically have to go and change your business processes to meet how that software works. If you don't, it's a lot of customization and a huge amount of work. And there's consultants that make hundreds and hundreds of thousands of dollars a year doing those sort of customizations. On the other end, you've got people that are going to build it themselves from scratch. You've got a company that's big enough, like a UPS. UPS and FedEx have had for 15 plus years package tracking solutions. And they built them up, and they spent probably hundreds of millions, if not billions of dollars building those solutions. But there was enough of a return on their investment to do that it was worth building it from scratch. In that middle 60, 75%, whatever, you have people that want to get part of the way to a solution, 80% of the way to a solution with an out-of-the-box technology that's flexible enough that it can then be able to be customized to meet their business processes, their business needs, to be able to integrate multiple vendors' hardware, multiple vendors' software, those sorts of things. So if you look at open source has been the driving engine behind transformation for the last, I'd say, 10 years. If you look at cloud, if you look at, application development, most of these things have all come out of open source. Container technologies, although, they did sort of originate with Sun back in the day, have really, with the addition of orchestration and things like that, have really begun to prosper under open source. So if you look at open source adoption, 78% of the enterprises today have adopted open source in a significant manner. And this comes from Black Duck. So in a non-trivial way, not having an open source library and software they bought, but actively running open source software. And 65% of companies are contributing to open source software in one way or another, whether that's funding organizations that maintain and manage open source software, creating bugs, creating documentation, actually contributing code, testing, all those sorts of things. So, open source is a way of life. So, the way that open source drives rapid innovation is by the ability of many companies to come together and work in an open environment and do joint research and development without a lot of overhead. So you have something like Cura, where you have Eurotech going and open sourcing Cura from ESF. And then you have companies coming in and beginning to work on it, like large SI. Microsoft contributing a connector to allow you to route data to Azure. Red Hat coming in and helping integrate Camel. You have all these different companies coming in and beginning to use request features, report bugs, or like Red Hat, donate code to the project, donate a connector between Camel and ESF. So you have the ability to rapidly prototype, rapidly evolve software, and coordinate between a relatively large number of companies together and individual entities. There's plenty of people that are individually contributing to these projects as well. This is particularly important in the IoT space because the solutions are not necessarily unique. There may be unique aspects to them, which is why the architectures need to be pluggable, they need to be extensible, but solving a device management problem, there's a lot of commonality in what you have to do. There's a lot of common standards that are out there that you have to support, like lightweight M2M, CoAP, MQTT. So where there's a lot of well-defined standards, open source does a really good job of going in and taking those standards and implementing different ways to do them. So you also have competition because you have Mosquito, you have ActiveMQ, you have different software. They're trying to solve different problem sets. So that's one of the goals in IoT and in Eclipse IoT is to be modular enough that if you want to start with MQTT, you can then, if your needs change and you want cloud scale, you can go to a different messaging product. You can go to ActiveMQ, you can go to Dispatch, and then en masse, and different things like that. So it gives you the flexibility to be able to change out components as they evolve. So open source fueling IoT really gives you three things. One, you're able to build for interoperability. So you're able to, through the open source development model, different companies come in and they may have proprietary software even, but they want to create connectors that make that open source software interoperable with their software. So it's not just that one piece of open source code is interoperable with another piece of open source code, which does happen quite frequently, but open source software is connectable to proprietary software. So proprietary vendors will contribute connectors to open source software and allow you to interact with it. We talked about this before, but the open source development model drives shared R&D innovation, and that's crucial to the success of IoT. You're going to have multiple hardware vendors working together in shared projects to create drivers and interfaces and APIs and things like that are going to work across multiple vendors, because I think most of the customers that are out there and consumers and project users are going to want to have something that works across, Honeywell, Rockwell, Bosch, ABB. They're going to have a heterogeneous mix of hardware. They're not all going to buy from one vendor. And then lastly is flexibility. If you look at the evolution of software over the last 10 years, you've seen different pieces of software evolve. So you've seen, things like Java, you've seen JavaScript, you've seen these different pieces of application development environments migrate into cloud infrastructures, into containerized infrastructures, things like that. So you're going to continue to see, whereas a proprietary solution may be coded so strictly that you've coded to be an on-prem software solution that is going to be hard-coded to run in a customer data center. Open source architectures are typically flexible enough over time, and you have enough people working on them that and contributing from the new technology vendors that you're going to be able to migrate them more quickly and more efficiently. So a testimonial as to why Open IoT is the best strategy. You look at companies like Bosch, GE, Eurotech, Red Hat. There's lots of companies that are out there that are contributing to open source. And Dr. Stefan Ferber said that we believe the best way to support this complex environment is to base our commercial IoT platform, the Bosch IoT suite, on open source components. And Ben alluded to this. These projects establish a horizontal open technology for IoT and provide the technical breeding grounds for successful business ecosystems. So the goal of Eclipse IT is essentially to establish a set of horizontal technologies that you can then build vertical solutions on, like the smart home initiatives and things like that, and to build them in a way where you can plug in additional pieces of functionality through APIs and through shared data models and things like that. So if you look at the type of functionality that you're going to have in IoT, you're going to have, and this is something that we came up with Eurotech, multiple layers of functionality. You're going to have the data endpoints. You're going to have field connectivity, which is things like Bluetooth, CAN bus, Modbus, non-routable local area communication standards. And so those are going to be down at the device level itself. Those are going to connect to a multi-service gateway or multi-protocol gateway that's going to do data acquisition off of these different buses and communication methods, and they're going to control them as well. They're going to do data pre-processing, so they're going to acquire the data off the bus. They're going to take the data, they're going to summarize it, normalize it. They may intermittently send the data when the conditions are normal, but they may switch to a verbose logging schema when the data or when there's an error condition or a warning condition, things like that. And then there's edge analytics and intelligence. And edge analytics and intelligence, you're not going to be running something that is looking for, across a week's worth of data, across 100 sensors, things like that. But what you are looking for is a short sliding time window with multivariate windows so that you can look at, say, RPMs, temperature, vibration, 3 or 4 different variables, and you can look at them over a 30-second window. And if vibration begins to go over a threshold, then you start looking at temperature. And if temperature goes over a threshold, then you shut the machine down. Or you go from sending a message every 10 seconds to sending every reading that's coming out of the machine. So you have to have, at that gateway level specifically, you have to be able to aggregate this traffic and summarize it. And we think if you look at something like Cura, it's extensible enough to lend itself to Industry 4.0 today, Industry 4.0, transportation, a lot of different use cases that are out there. So you're able to take this open source software and within the paradigm of the OSGI container and the Cura services, build this functionality. There's also back-end network connectivity, which is typically going to be it could be REST-based, but it's probably going to be MQTT, AMQP, some sort of messaging-oriented protocol. Could be CoAP. And then you've got on the cloud at the IoT integration platform, which would be Kapua. In the case that we're discussing, you have information ingestion and control, and you have information processing and integration. So you're basically going to bring that data in. You're going to take that data and you're going to split it potentially, route it to different applications, route it to different consumers. And you're also going to take data and commands from applications and management applications and enterprise applications and send that data southbound back down as control messages. So you're not only processing northbound telemetry, but you're processing southbound. So you need a platform like Kapua where you will have a core set of services by default that you can develop against, but then you can go and replace message ingestion with Hano. You can replace device management with Hawkbit or Layer Hawkbit as part of the technology. So you need something that's going to be flexible enough, and when a new technology comes along, has the ability to extend and integrate those new services. Along with this, you have foundational security and management functionality, device registries, device updates, certificate management, all those sorts of things. And those are built in at every layer of the stack. So that's the other thing about an open source IoT solution that you're not going to get from a hodgepodge that's built by somebody else. This is built and integrated to integrate the same security mechanisms, management mechanisms all the way through, and for those to be pluggable and replaceable so that if something new comes along, you can plug it in at Cora and you can plug it in at Kapua. And then at the top, there's data stores, BI and analytics, and enterprise application services. So the data stores can either be internal to Kapua, or they can be external data stores. The data stores within Kapua by default is Elasticsearch, but it is changeable, so you can change that to any other data store. Or you could have an external data store like a Hadoop database or something like that, where you're storing the data, storing long-term batch analytics in Hadoop, and then doing analytics on it, and then feeding that back down as rules to the complex event processing down at level 5 at the gateway. So having all these tools, both the cloud side and the gateway side integrated, allows you to have feedback loops of software back down the stack, not just northbound and up. And bringing up what Ben had before, these are the targeted pieces of functionality that you're going to have with each. So you have the Eclipse projects that Ben mentioned at the constrained device, at the gateway, and smart device. So if you have an MRI machine, it could be running Cora and running Camel and Drools and a bunch of different Java software inside of it. So it's not just necessarily a comms gateway. It could be a hardened server in a rail yard that's intaking data about the sensors and managing the switching of the lines in the yard to get the right cars on the right trains. Or it could be a medical, a high-end medical machine, high-end manufacturing machine, things like that. So don't think of that middle tier with Cora necessarily as just gateways, comms gateways. There's a lot more that they can do. And then at the Kapua level, you're managing all of the devices that are architecturally beneath, and you're going and managing the entire infrastructure. So, with this complete picture, you're able to then manage both northbound and southbound. You're able to manage the life cycle of the devices, manage the flow of data to the applications, integrate enterprise applications, including pre-existing applications. With Camel, you can integrate things like SAP, Salesforce, ERP systems, things like that. So you have a lot of flexibility even in the cloud in how you're able to plug things in. And just for time's sake, this is an example of using Vertex, Hano, Cupid, which is an Apache project, Artemis, Kafka, Kapua, and Spark together, having data come via AMQP, MQTT, HTTP, CoAP, and having data come directly from Cora. So you're able to basically replace the default Kapua data ingestion, which is ActiveMQ, and replace it with a Linux containers that are horizontally scalable with the Hano architecture with these other projects. Cupid is a network messaging-oriented middleware router. Artemis is a broker, a messaging broker. Kafka is for ingestion, obviously, for data ingestion into Spark or other data stores. So this is just an example architecture of how you can take Kapua and build an architecture around it for data ingestion and data processing. And we can skip the rest of the slides. So any questions? Yes, sir.
According to the current market, we can still see that proprietary IoT platform is still dominating. For example, the top 10 IoT platforms service providers that don't adopt open source platforms. So what's your understanding of the recent background, or what's your foreseeing?
So if you, how are they measuring the top 10?
I have seen some consultant analytics.
Yeah.
So for example, the platform from IBM, from Microsoft, from SAP.
Yeah. So if you look at, I think there's two sets. There's the cloud providers themselves, and so Google, Amazon, Azure. And while they're great to execute, and you could take this entire architecture and execute on top of any of them, and you could move from one to the other potentially, if you buy into Azure IoT services, if you buy into AWS, IoT services, those sorts of things, you're locking yourself in. I tend to think that the consultants and the analysts are overestimating the amount of revenue that anybody's getting from these. Every vendor that I have a conversation over a beer with, they have a lot of POCs and a lot of pilots and a lot of small dollar revenue that comes out of it. But they're counting existing revenue from existing software sources into those numbers. So, I think there is right now a marketing and market advantage to a lot of these players. I still don't think, nobody's won the race by far, and there's a lot of problems to be seen. A lot of these big industrial companies are having or one that I can think of in particular is having trouble getting their own business units to adopt their IoT platform because they've got existing software that they sell to customers that does aircraft engines or other things, and switching over is a large cost and could put revenue at jeopardy. So I would say that there's the state of the market today, which probably is because of the way revenue's counted and everything. The big proprietary vendors have a lot of mind share and probably have publicly say they have X amount of revenue. But from every one of them that I've talked to and from the large SIs I've talked to, I think that the field is wide open, and that I see more and more of the big SIs, which I think is the indicator, beginning to migrate towards open source as part of their solution stack. And so I think that's where we're going to see, because the market for open source, I think, really is these SIs going out and coming and saying, hey, we can get you 80% of the way there, and it'll cost you $1 million to implement the rest of the system, or we can build it from scratch, or you can pay X company, $10 million or, whatever. So I think as people move from where they are now, which is a lot of testing and piloting and, things like that you're going to see open source blossom more and more commercially and begin to overtake the proprietary vendors. But there is a share of the market that the proprietary vendors are just going to have, period, completely, and that's it. But even the proprietary vendors you can see are opening up to open source as a source for software. And it's a question of whether, companies like Red Hat and Eurotech can monetize this, or whether, the GEs of the world and ABBs and other companies like that, Siemens, whether they're going to drive the open source ecosystem and sort of have a détente and all begin to work together. But I think if you look at the big industrial companies, they're already starting to begin to work together in communities. Yes, sorry. Go ahead.
Well, your last comments were great.
Yeah.
I'm going to focus on that for a second if I could. So when one goes to a gateway or further
Yeah.
stack, that's implied latency.
Yeah.
And the idea is that if we can generate, because I think latency is probably the number one problem.
Yeah. So one of the reasons to have a gateway is to drive latency out. So that's why you drive the decision making to the gateway itself, and you give it a set of decision making capabilities to instead of having, in a factory, instead of having to go all the way to the cloud, you go to the closet in the factory and come back.
Sure.
Yeah.
Let's take this on.
Yeah.
What if developers just somehow work through Eclipse or some sort
Mhm.
of plugin to manage their ontology to ontology differences?
Mhm.
So they can affect peer-to-peer decisioning, because
Ye-
you and I know that about 5 to 8% of that data is control data.
Right.
And all that other junk just goes up the stack.
Right.
Clogs the wheel, makes it expensive, makes us look bad.
Right.
So you see, and I know this cuts big companies like, big
Yeah.
companies out, but you envision a world where the ontological difference between people who manufacture things is bridged by having their ontology, their specific objects, properties, and attributes, talk to one another if they want. And when's it gonna happen?
So I think there will be peer-to-peer communication. I still think there will need to be an entity that manages that within an area. I think some of this is going to evolve into the telco infrastructure. I think we're going to see more and more of central offices and cell tower base stations having applications run in them that help negotiate that communication. But I don't think, I think at some point you have to have a decision point of what data to send to the cloud for analytics, because there is a funnel of data that has to go up into that cloud. And so you're going to have something that is making the decision of what to throw away, what to average, and what to summarize and batch and send up later and things like that. So, I think even if you take out the decision-making capabilities, there's do I turn on, do I turn off, what's the state of this, what's the state of that? There's still, you're going to have, there's not enough bandwidth, and the bandwidth is too expensive to send everything up. So you're going to have something that is an arbiter of that.
Do you want to say the word smart bridge yet?
No, I don't want to say that. I think I've gone over my time, so
Fine, that was a great presentation, actually. Thanks, James.
thank you very much.